During round-the-world travels around our planet, the calendar date count inevitably fails. To eliminate confusion, scientists drew a demarcation line along the 180th meridian. Crossing this boundary from west to east, you must repeat the current date. Magellan's travelers were the first to discover the loss of a whole day.
The international date line. It's not just some arbitrary line drawn on a map for convenience. It's a fundamental consequence of living on a rotating, spherical planet. It's a physical necessity, a solution to a very real problem created by how we measure time itself. So let's dissect why it must exist and precisely how it functions.
So let's start with the most basic question. Our Earth is in constant rotation. The sunrise is a continuous wave moving across its surface. There's no natural starting or stopping point. So where on this spinning sphere do we decide, by convention, that a new calendar day officially begins? There has to be a designated line.
All right, here's our roadmap for this lecture. We'll begin with the circumnavigation paradox, which is the core logical problem that requires a solution. Then we'll examine the solution itself, the demarcation line. After that, we'll break down the specific rules for crossing it, both west to east and east to west. And we'll conclude with the historical precedent that first brought this entire phenomenon to light. Okay, let's start with a thought experiment. This is the best way to grasp why the date line is not just an idea, but an absolute necessity. Picture a traveler setting out to circumnavigate the globe.
So imagine this traveler heading east, moving with the rotation of the Earth. With every single time zone they enter, they must advance their clock by 1 hour to align with the local time. They're essentially moving towards the sunrise, making each of their days slightly shorter than 24 hours.
Now, as they complete their journey, passing through all 24 of the Earth's time zones, those 1-hour advancements begin to accumulate. 1 hour, then another, until they arrive back at their exact starting point. And here is the result. By the time they get back, they have set their clock forward a full 24 hours. Their ship's log, their personal experience, shows that one more day has passed than the calendar at their point of origin. They have gained an entire day.
Now, let's consider the opposite scenario. A traveler leaving from the same spot but heading west, against the Earth's rotation. For every time zone they cross, they have to set their clock back 1 hour. They're moving away from the advancing sunrise, which makes each of their days slightly longer.
So when this westward traveler completes their journey and returns to the starting point, their logbook is a full day behind the local calendar. They have effectively lost a day from their count. This is the essence of the paradox. 2 travelers, 1 journey, but a 2-day difference in their records. This discrepancy must be reconciled.
So, how do we solve this? The solution has to be a formally agreed upon line, a single place on the planet where we can correct for this accumulated gain or loss of a day. This is the function of a demarcation line.
And that line is, of course, the international date line. By international agreement, it's the official boundary where each new calendar day begins. It's positioned, for the most part, along the 180-degree meridian of longitude, which places it in the middle of the Pacific Ocean, directly opposite the prime meridian in Greenwich.
Now, if you look at a map, you'll see the line isn't perfectly straight. It actually has several significant deviations. And these aren't random. They are purely for practical, political reasons. The line zigs and zags to avoid bisecting a single country or a group of islands. You can imagine the absolute chaos if one side of your village was living in Tuesday while the other was in Wednesday. These deviations ensure entire nations remain on the same calendar date.
So what happens when you physically cross this line? It's all governed by 2 fundamental and opposite rules. When you cross heading from west to east, you decrease the calendar date, you actually repeat a day. And when you cross from east to west, you increase the date, you skip a day entirely. Let's look at each of these in detail.
Okay, first, let's analyze an eastward crossing. Think of a journey from Asia towards the Americas. This is the direction where our traveler was accumulating time.
So, as your vessel approaches the line from the west, you are in the later day. Let's say it's Tuesday. The moment you cross that line, the calendar must be set back 1 full day, to Monday. The result? You get to live through the same calendar date twice.
Here's a very clear example. Let's say a ship crosses the line on November 8th. After crossing, the next day at midnight isn't November 9th. No, the calendar is reset. The next day is again November 8th. You repeat the day to reconcile the 24 hours you gained on your eastward journey.
Now, let's reverse it and examine the westward crossing. This is the journey from the Americas towards Asia. where our thought experiment traveler was losing time.
When you approach the line from the east, you're in the earlier day. Let's call it Monday. The instant you cross the line, the calendar must jump forward one full day to compensate for the time deficit you've accumulated. This means an entire 24-hour period is simply skipped over.
Let's use the same date to make it clear. A ship crosses the line going west on November 8th. The date doesn't become November 9th, it immediately becomes November 10th. For every single person on that ship, the day of November 9th in that particular year simply ceases to exist. It never happens.
Now, this entire system isn't just a theoretical construct. These rules were established to solve a very real-world problem, one that was first discovered empirically by the first humans to ever circumnavigate the globe.
Right, back in the 16th century, the surviving members of Ferdinand Magellan's expedition returned to Spain. They had completed the first circumnavigation of the Earth, traveling consistently westward. Upon their return, they were shocked to find that their meticulous ship's log was one full day behind the date on shore.
They were certain they had not made a mistake in their count. Their voyage served as the first concrete, historical proof of this circumnavigation paradox. By traveling west around the world, they had literally lost a day from their calendar. The establishment of the international dateline directly addresses and rectifies the exact error they encountered.
So you see, the dateline is an elegant and necessary human convention to deal with the physical reality of our rotating world, which leaves us with a truly fascinating question to ponder. This same paradox would exist on any rotating planet we might colonize, say Mars. How would we, as a species, decide where to draw its prime meridian? Where would we establish its international dateline? The physics would be identical, but the politics of defining where a new Martian day officially begins, well, that's a whole new frontier.
Thank you, friends. Strive for understanding and become wiser. See you soon.